Okay, welcome to day 1 of Unit 9. This is our radical unit. We'll also talk about inverses in it. Okay, and the first thing we're going to do is we're introducing two new functions, the square root function and the cubed root function. So we'll look at both of these. And today we're looking at transformations as well as their characteristics. So let's plug in the square root of x into your calculator. Oops, let's clear that out. So x. And I want to take a look at the graph. And notice the graph starts at the origin and then just continues going towards the right and going up slightly. If I look at my table of values, notice for the negative values of x, we just have an error. That means it does not exist when x is less than 0. So if x is less than 0, error. When x is 0, we have 0. When x was 1, my y value is 1. When x is 4, y value is 2. And when x is 9, the y value is 3. Now if I were to graph this, I start at 0, 0, and then 1, 1. So 1, 1, 4, 2, and 9, 3. Of course, we have the arrow to show it continues in that direction. Notice there's no arrow on this end because it does not continue. That is my starting point there. So my domain, I can go from 0 to anything bigger than 0 in x. So this is the set of all x's such that x is greater than or equal to 0. I could also write it as an inequality. So 0 is less than or equal to x, which is just less than infinity. I could even use the parentheses and brackets, so 0, comma, infinity. So the square bracket means we get to 0, parentheses means we never get to infinity. My range, I start at 0, that's my lowest y value, and then I just get higher and higher, so I get larger. So it's the set of all y's such that y is greater than or equal to 0. I can also use the inequality. 0 is less than or equal to y, which is less than positive infinity. And I could even do my little interval notation. All three of these mean the exact same thing. Okay, let's take a look at our our cube root function. And this little part here, the 3, that is called an index. So that tells you what root we want. The x is called your radicand. Okay, and to put this in the calculator, let's clear out what I have. I need to have the cubed root. So to get that, if you go to the math button, the fourth option is the cubed root of something. So we want that, and we'll put in x. And let's take a look at our graph. So it comes from the lower left, comes up, goes through the origin, and then continues. So as x gets bigger, the y values gets bigger. As we go to the left, so as x gets smaller, my y values get smaller. So let's fill this in. Take a look at our table here. And the first value I want is when x is negative 8. So when x is negative 8, y is negative 2. When x is negative 1, y is negative 1. X is 0, y is 0, 1, and then positive 2. So if I'm going to graph this on my paper, negative 8, negative 2, negative 1, negative 1, 0, 0, 1, 1, and then 8, 2. So it comes like, flattens out a little bit, and then continues. And we're putting the arrows here because this function does continue in both directions. So my domain, it looks like I can have any values that are negative. I can have when x is 0, and I can have positive. So it is the set of all x's such that x is an element of all real numbers. We could also write this as just all real numbers, or if we use our interval notation, it'd be from negative infinity to positive infinity. Likewise with the range, we go here, we keep getting smaller, very slowly, but we do get smaller in y. And if we go in this direction, it is increasing or getting larger. So it is the set of all y such that y is a real number. Or we can write all real numbers, which is everyone's favorite way to write it. Or we can use the interval notation, negative infinity to positive infinity. Okay, so some similarities. They both have 0, 0 in them. They both have the point 1, 1. Okay, as x gets bigger on both of these, y is also getting bigger. However, my cube root function does exist on the left half of the graph, whereas the square root does not exist there. Okay, so let's take a look at some transformations now. We have the quadratic transformations listed here, and the rationals. You should be familiar with those. So we're going to do the same thing with our square root now. If I want to stretch this or shrink this, so if I stretch or shrink, I need an a value. If a is bigger than 1, it's a vertical stretch, and I'm going to put a v here for vertical stretch or vertical compression. That's the word we tend to use. So the equation would look like f of x equals a times the square root of x. If I want a horizontal stretch or compression, again, let's put that h in there. It's my b value which changes. And the b, if you remember on the quadratic, was in with the x and then got squared. With my square root, it's the same thing. It's going to be the square root of b multiplied by x. If we want to reflect in the x-axis, so here's my x-axis. If I want to, if I want to reflect across the x-axis, then that means I'm going to change these. I need a to be, this is vertical here, and this one is horizontal right here. So if you want to do this, you'd have to check both of those.